Convert each of the following to the base indicated. So if we have 9 to the 2x, and we want to write this as 3 to the something, we don't want 9 to be our base anymore. What you have to do is replace 9 with 3 to the something. Well, 3 to the 1 is 3, 3 to the 2 is 9, and so we can do this. There's our 9 to the 2x, but where 9 used to be, I'm going to write 3 squared instead. Okay. The exponent stays put, and the base gets changed from 9 to 3 squared, which still means 9. Now, after you've done that, you want to clean it up. We have these stacked exponents here, which we can multiply together, and that gives us 3 to the 4x. So when we get equations, sometimes we'll have an equation where base 9 is not helping us, and we wish we had a simpler base. This is one of the options we have. Rewrite 9, replace it with 3 to the something. Here, same thing. We have the base 125, and they're saying, could you write that as 5 to the something? Well, 5 to the 1 is just 5. 5 to the 2 is 25. 5 to the 3 is 125. So, where the 125 is, we can put 5 to the 3rd, and the power outside is still there. And now again, we multiply these two exponents. So we get 5 to the 3 times 2 is 6, and 3 times negative x is negative 3x. 8 times 16 to the x to base 2. Now we have two bases, 8 and 16. These are trouble when you have two different bases, but the good news is both of these things can be written as powers of 2. 2 to the 3rd power is 8, and 2 to the 4th power is 16. So where the 8 was, we can put 2 to the 3rd instead. Where the 16 was, we can put 2 to the 4th instead, and that's to the power of x. And now we clean this up. The 2 to the 3rd we can't do a heck of a lot with, but 2 to the 4 times x is 2 to the 4x. And we can do something else, since these bases now match. We can add them together and get 2 to the 4x plus 3. If you want to write 3 plus 4x, that's okay, but because this is of polynomial form, I'm trying to write it in descending order. That's the nice way to express these. That's the standard we try to follow all the time. So this is the first one where changing bases has actually helped us. It revealed that 8 and 16 are both powers of 2, and if they're both powers of 2, you can squish them together into a single term. 1 over 512 to the 3x. Okay, powers of 2. 2, 4, 8, 16, 32, 64, 128, 256, 512. You can't see me counting on my fingers, but I have 9 fingers up right now, which tells me 2 to the 9th is 512. So we can write this 1 over 512 is 2 to the 9th power, and that's to the 3x. Stacked exponents, so we can express that as 1 over 2 to the 27x, because you multiply those powers together. And you could stop there, or because it's a reciprocal, it's kind of tempting to write 2 to the minus 27x to get it out of fraction form. I don't know which one of these they prefer. I would be a little bit inclined to go with the second one without the fraction, but they're both reasonable. Now, fraction. We have to take 2/3 and power it up until it makes 16/81. Well, if you square this, 2/3 squared is 2 squared over 3 squared. To the 3rd power, you get 2 times 2 times 2 over 3 times 3 times 3. And to the 4th power, you get 2 times 2 times 2 times 2 over 3 times 3 times 3 times 3. Ta-da! There it is. 2/3 to the 4th power is 16/81. So we have 2/3 to the 4th. I need an extra layer of bracketing here. There we go. 2/3 to the 4th power is 16/81, and then all that is to the x plus 5th power. These are stacked exponents, so you multiply them, you get 4 times x, and you get 4 times 5. So this ends up being 2/3 to the 4x plus 20. You could write that as 2 to the 4x plus 20 over 3 to the 4x plus 20. I don't think there's any real benefit to doing that. You can do it if you like, but this is where I think I would stop.